In this video, we're going to look at some harder quadratics. So up until now, we've been dealing with quadratics, for example, like x squared plus 5x plus 6. And one of the things you've noticed here that we had just had an x squared. We didn't have a number in front of the x squared, which is what we call our a value. So what I'm going to do is I'm going to cover off doing some examples of questions where we have a number that's greater than 1 for our x value. Now, we're going to do really simple ones because at year 10, we've got to keep this simple. When you get into year 11, we teach you another technique for even harder questions, and at year 12, it gets even harder still. But at year 10, we keep it quite simple. So for example, if I give you this question here, so I want you to factorize 2x squared plus 20x plus 32. Now, like I said, it gets harder as you go up through the years, but at year 10, we're going to make it quite simple for you, and that the way to solve these problems is what you need to do is you can divide through by a common factor. And that common factor in this case here is 2, because 2 goes into 20, goes into 32. So if we divide through each of these terms by 2, we end up with the following. So we'd end up with 2 outside the brackets, and then we'd have x squared plus 10x, oops, not squared, plus 16. Okay, so, oops, I've done a little mistake there. That should be just a plus. So we can ignore the 2 now. So we're just left with basically x squared plus 10x plus 16. So I'll just draw a line here, and we've got x squared plus 10x plus 16. And we now just go through the same process as we did with the other quadratics that we've been working on. So first of all, we've got our plus 16 out the back here. What are the factor pairs of 16 or plus 16? Well, you've got 1 and 16, plus because it's a positive, we'll have -1 and -16. You've got 2 and 8, and of course -2 and -8. Oops, that's an 8. And you've got 4 and 4, of course. Okay, and -4 and -4. So what we need to do here is find which one of those combinations adds to get positive 10. And of course, if you were to do all of that, you'd end up with 2 and 8. So our answer, therefore, to this particular problem is x plus 2, x plus 8, and then we've got to bring the 2 down and put it outside the front there. Okay, because that, when we expand it out, will get us back up to here. So don't forget the 2 that you've already divided out. That's got to go in front, or whatever number that is. I'll give you another quick example here. So we're going to do another question here, just to give you a bit more practice. So I want you to factorize, see if we can fit it on the bottom of the page here, factorize 4x squared minus 8x minus 60. So the first thing you're going to do is you're going to look through this and say, what is a common factor between 4, 8, and 60? And you'll know straight away that obviously it's not going to be anything larger than 4, and 4's go into both 8 and 60. So if we divide through by 4, we're going to end up with 4, and then brackets, x squared minus 2x minus 15. And so now we're going to factorize the x squared minus 2x minus 15. So if we put our factor pairs of 15 out here, and it's minus 15, so we're going to have 1 and -15. And of course, we'll also have -1 and 15. And then the other factor pairs of 15 are 3 and -5 and -3 and 5. And so we now look at the groups of numbers there, and which ones of those add to -2? And of course, it's going to be 3 and -5. So our answer in this case here would be 4. We bring the 4 down, And then we open the bracket and we go x plus 3, open another bracket, x minus 5. So that's how we do those sort of factorising harder quadratics. We'll go on to the next slide and I'll show you another harder quadratic. So the other sort of harder quadratics you sometimes get, in fact, these aren't even quadratics, they're what we call polynomials. So it's not really a quadratic. I'll actually just put in brackets here, polynomials. Okay, so polynomials are where you've got an x squared or an x cubed or something like that. So we'll do an example of one of these. And so our example that I'll do here, just do my pen. Let's have something like x cubed. So we get x cubed minus 11x squared plus 24x. And you're looking at this and going, how am I going to solve this particular problem? Well, it's actually a lot simpler than you think. What you need to do is think, what are the common factors between each of these terms? And you'll notice in each of these terms, all of them have got an x in them, haven't they? So if we divide through by x, what do we end up getting? So we'll take the x out and we say, well, we've got x, and then open up a bracket. What's x cubed divided by x? Well, that's x squared. What's minus 11x squared divided by x? Well, that's minus 11x. And what's plus 24x divided by x? Well, that's plus 24. And all of a sudden, you've got something that looks like you could actually solve that. And of course, that's a quadratic. So now we just go through the same steps as we went through on some of our earlier quadratics, and we say, okay, what are the factor pairs of positive 24? And I'm going to take a bit of a shortcut here because you should know this by now, but if you've got a positive number here, you know that the signs are the same, and because this is negative, both of them must be negative. So the factor pairs of positive 24 that are both negative, well, you've got negative 1 and negative 24. You've got negative 3 and negative 8. You've got, I'll just put a line here, you've got 2 and 12, negative 2 and negative 12. And of course, you've got negative 4 and negative 6. Okay, so which one of those factor pairs adds to negative 11? And of course, it's going to be negative 3 and negative 8. So we know that our brackets are going to be x minus 3 and x minus 8. But don't forget to bring this x down as well. So if I was to expand all those out, I'd end up with this polynomial, which is in fact a cubic because we've got an x cubed. And that's how you do those questions.